Hello, this is Proof by Cases by Group 5, consisting of myself, Xavier Lomeli, and Avernethy Francisco. Definition: in discrete mathematics, proof by cases is a technique used to validate statements by separating the proof into various cases and proving each one individually, thus proving the whole by first proving the parts. Utility: this approach is particularly useful when a problem statement can be subdivided further into distinct non-overlapping statements/scenarios. This is also true when an alternative proof that encompasses the entire domain of the statement is particularly difficult, cumbersome, or otherwise time-consuming. Example 1. Prove for every integer x squared minus x is an even integer. In case 1, x is assumed to be even. Since x is even, x equals 2 times k for some integer k. Substituting 2 times k for x in the equation yields 2 times k squared minus x times k, which reduces further to 4 times k squared minus 2 times k. Since k is an integer, 2 times k squared minus 2 times k is likewise an integer. Thus, x squared minus x is even. In case 2, x is assumed to be odd. Since x is odd, x equals 2 times k plus 1 for some integer k. Substituting this for x in x squared minus x yields, in parentheses, 2 times k plus 1 squared minus, in parentheses, 2 times k plus 1, which reduces further to 4 times k squared plus 2 times k, from which the value 2 can be factored out, meaning since k is an integer, 2 times k squared plus k is also an integer. Thus, x squared minus x is even.
For example 2, we're going to prove that for every real number x, x squared is greater than or equal to 0. And we'll split this up into 3 cases. For the first case, x is less than 0, and since x is less than 0, we multiply both sides of the inequality by x. And this inverts the inequality since the negative number by a negative number is a positive value, which is at least greater than or equal to 0, and leads us to x squared is greater than 0. So the implication is that the inequality x squared greater than or equal to 0 still holds. In the second case, we'll assume that x equals 0, and again multiplying both sides of the inequality by x leads us to x squared is equal to 0, and then this leads to holding that x squared is still greater than or equal to 0. In the third case, we assume that x is greater than 0, and again we multiply both sides by x, so we get x squared is greater than 0, and since x is positive, the inequality doesn't flip, so x squared is greater than 0, and again implies that x squared is greater than or equal to 0. And since all 3 cases presented above lead to the conclusion that x squared is greater than or equal to 0 in each of the cases, therefore we conclude that x squared is greater than or equal to 0 for all real numbers.